The Atlantic Ocean, usually a canvas of restless gray, is calm on this particular morning in 1964. But beneath the surface, a war game is reaching its climax, and the results are about to terrify the admirals of the North Atlantic Treaty Organization. A fleet of destroyers, frigates, and aircraft has spent 48 hours hunting a single target. They have dropped sonobuoys, they have pinged the depths with active sonar, they have listened with the desperation of men who know their careers are being graded, and they have found absolutely nothing. On the bridge of the flagship, the Commodore checks his watch. The exercise is over. He orders the signal to surface. Smoke grenades pop on the water, marking the end of the hunt. The officers scan the horizon, expecting the target submarine to break the surface miles away, perhaps near the boundary of the exercise box, having used speed to escape the net. Instead, the water boils less than 2,000 yards from the flagship's hull. A black sail breaches, followed by a stubby, awkward hull that looks nothing like the sleek sharks of the nuclear fleet. It is the USS Tullibee. She has been there the entire time. She has been sitting in the acoustic shadow of the fleet, matching their speed, listening to their screws turn, and logging theoretical kill shots on every capital ship in the formation. The most expensive anti-submarine warfare force in the world has just been defeated by a boat that many in the Navy considered a mistake. The captain of the Tullibee orders the hatch open. He does not smile. He knows that he has just proven a point that the Navy does not want to hear, that the future of warfare is not about being faster or stronger. It is about being nothing. To understand how this moment came to be, we must go back 4 years to a cold pier in New London, Connecticut. The date is November 9th, 1960. The commissioning ceremony for the USS Tullibee, SSN 597, is a formal affair filled with brass bands and speeches about the marvels of atomic power. But beneath the patriotic bunting, there is a current of skepticism. The officers of the submarine force look at the new boat with a mixture of curiosity and disdain. She is small, barely 273 feet long, displacing only 2,600 tons, in an era where bigger is better and nuclear power is synonymous with unlimited speed. The Tullibee seems like a step backward. She is powered by a small reactor, the S2C, which generates a fraction of the horsepower of the fleet standard S5W. Her top speed is classified, but everyone knows it is slow, painfully slow compared to the hot rod Skipjack class that can hit 30 knots. They call her a toy. They call her a science project. Commander Richard Jarkowski, her first captain, knows the whispers. He knows that his ship is an anomaly. The Navy is building a fleet of fast attack submarines designed to chase down Soviet missile boats and outrun torpedoes. They value speed, aggression, and deep diving. The Tullibee has none of these things in abundance. She is a defensive weapon in an offensive culture. But Jarkowski also knows the secret that lies in the engineering spaces. The Tullibee does not have a reduction gear. She does not have a mechanical drivetrain connecting the turbines to the propeller. She has something else, a turboelectric drive. A steam turbine turns a generator, which produces electricity, which powers a massive electric motor. It is complex, it is heavy, it is inefficient, but it is silent. The sewing machine Submarine, as her detractors call her, makes no gear noise. She has no mechanical scream. When she moves at slow speeds, she makes less noise than the ocean itself. She is the physical embodiment of a radical idea that was born not in a shipyard, but in a conference room. The genesis of the Tullibee lies in the summer of 1956 at a place called Woods Hole in Massachusetts. The National Academy of Sciences had convened a gathering of the brightest minds in physics, oceanography, and naval strategy. It was codenamed Project Nobska. The mood at Nobska was grim. The Soviet Union was building a massive submarine fleet. Their boats were loud and crude, but they were numerous. American intelligence analysts projected that by the 1960s, the Atlantic would be swarming with hundreds of Soviet submarines, potentially cutting the lifeline between the United States and Europe in a Third World War. The admirals wanted to build faster submarines to hunt them down. They wanted more torpedoes. They wanted nuclear depth charges. But the scientists at Nobska looked at the physics of sound and water. They looked at the rate of technological improvement in sonar, and they came to a brutal conclusion. Speed is a trap. The faster a submarine goes, the louder it gets. Flow noise over the hull blinds the sonar. Cavitation from the propeller announces the position to the enemy. A fast submarine is a deaf submarine, and in a nuclear war, if you are deaf, you are dead. The Nobska report proposed a new concept, the hunter-killer submarine. This vessel would not chase the enemy. It would ambush them. It would sit at the choke points, the gaps between Greenland, Iceland, and the UK, and wait. It would have a sonar system so sensitive it could hear a Soviet submarine leaving port in Murmansk. And it would be so quiet that the enemy would never know it was there. To build this ship, the Navy had to abandon its obsession with speed. They had to prioritize silence above all else. The report was controversial. It challenged the fighter pilot mentality of the submarine force. But the logic was inescapable. The Chief of Naval Operations authorized the construction of a single experimental hull to test the theories of Project Nobska. That hull was the Tullibee. So as she sat at the pier in 1960, she was not just a ship. She was an argument made of steel. She was a test case for a philosophy of warfare that said, detection equals death and silence equals survival. But for the men who would sail her, philosophy was less important than functionality. They looked at the strange hull form, the odd placement of the torpedo tubes, and the massive sonar dome in the bow, and they wondered if they were sailing in a weapon or a target. The unwanted experiment had begun. The Navy had built a submarine it did not truly believe in, hoping it would fail so they could go back to building fast ships. But the Tullibee was about to prove that the scientists at Woods Hole were right. The problem was not that the ship was bad. The problem was that she was too good for a Navy that wasn't ready to understand her. In the rigid orthodoxy of naval architecture, a submarine is built around a specific skeleton of assumptions. The bow is for weapons. The stern is for propulsion. The middle is for people. For 50 years, from the diesel boats of World War II to the nuclear pioneers like the Nautilus, this layout was sacred. But the USS Tullibee was not an evolution of this design. She was a blasphemy against it. To achieve the silence demanded by Project Nobska, the engineers at Electric Boat had committed 3 specific heresies that fundamentally altered the DNA of the submarine. The first heresy was visible to anyone who saw the ship in dry dock, though its true nature was classified top secret. The bow of the Tullibee did not taper to a sharp hydrodynamic point for cutting through the water. It was bulbous, swollen, and blunt, and crucially, it had no torpedo tubes. For a warship, removing the primary weapons from the front is akin to a soldier entering battle without a rifle in his hands. But the Tullibee had sacrificed her fist for an ear. Inside the massive fiberglass dome of the bow sat the ANBQQ-2 sonar array. It was not a cylinder or a flat plate. It was a sphere, a 15-foot diameter ball of steel and ceramic, studded with over 1,000 individual hydrophones. This was the first spherical sonar array in history. The physics of the sphere changed everything. A traditional cylindrical array listens in a 360-degree circle, but it struggles with the vertical plane. It cannot easily distinguish between a sound coming from the surface and a sound coming from the deep. The BQQ-2 could hear in 3 dimensions. It could listen up, down, and all around simultaneously. It could track a contact in the surface duct, the layer of water near the waves, while hunting another contact in the deep sound channel. It could use bottom bounce techniques, reflecting sound off the seabed to detect enemies over the horizon. This sensor was so powerful, so sensitive, that it required the entire front third of the submarine to support it. The Tullibee was not a submarine with a sonar. She was a sonar with a submarine attached to it. The sphere was the reason the ship existed. It transformed the vessel from a hunter into a listener. This led directly to the second heresy, the displacement of the weapons. If the bow is full of electronics, where do you put the torpedoes? The engineers solved this by moving the torpedo room amidships into the center of the boat. The tubes were angled outward, firing from the flanks of the hull rather than the nose. This design choice was a tactical nightmare. In a traditional bow-on attack, the captain points the ship at the target and fires. The torpedo runs straight. It is simple geometry. But with angled tubes, the torpedo has to execute a dogleg maneuver immediately after launch. It has to turn to acquire the target. This adds complexity to the fire control solution. It adds seconds to the engagement time. And in submarine warfare, seconds are lives. Furthermore, the midship arrangement limited the number of tubes. The Tullibee had only 4. A standard attack boat carried 6 or 8. In a target-rich environment, a World War III scenario where the Atlantic was swarming with Soviet submarines, the Tullibee would run out of options faster than her counterparts. She was a sniper with a bolt-action rifle in a machine gun fight. But the designers argued that she didn't need volume fire. With the BQQ-2 sonar, she would see the enemy so far away that she could take her time. She would fire one perfect shot from the darkness, not a spread of hopeful guesses. It was a doctrine of quality over quantity. The third heresy was the most profound and the most controversial. It was the heart of the ship, the turbo-electric drive. The standard nuclear propulsion system is a marvel of brute force. The reactor boils water, the steam spins a turbine, the turbine spins a set of massive reduction gears. The gears spin the propeller shaft. The reduction gear is the weak link in the chain of silence. It is a massive transmission, transferring thousands of horsepower from a high-speed turbine to a low-speed screw. As the steel teeth of the gears mesh, they scream. They create a tonal, a specific high-frequency whine that radiates through the hull and into the water. This tonal is a beacon. A Soviet sonar operator doesn't need to hear the whole submarine. He just needs to hear that one note to know an American boat is there. The Tullibee eliminated the gears. In the Tullibee's engine room, the steam turbine did not connect to a shaft. It connected to a generator. The generator produced electricity. Thick copper cables carried that current to a massive electric motor mounted directly on the propeller shaft. There was no metal-on-metal contact. There were no gears to grind. The motor turned the screw with magnetic force. The acoustic result was startling. When the Tullibee moved at slow speeds, she didn't hum. She didn't whine. She rustled. Her acoustic signature dropped below the ambient noise level of the ocean. To a passive sonar set, she sounded like water moving past water. She was a hole in the background static. But this silence came at a terrible price: efficiency. Converting mechanical energy, steam, to electrical energy, and then back to mechanical energy, propeller, is wasteful. You lose power at every step. The Tullibee's propulsion plant was heavy, hot, and complicated. The massive electric motor weighed tons. The generators required elaborate cooling systems, and she was slow. The top speed of the Tullibee was officially classified, but it was an open secret in the fleet that she struggled to break 15 knots submerged. The Skipjack could do 30. The Soviet November class could do 30. In the fast-paced, aggressive culture of the U.S. Navy, speed was life. Speed allowed you to intercept a target. Speed allowed you to run away from a torpedo. Speed allowed you to get to the battle. The Tullibee was a sitting duck. She couldn't run, she couldn't chase, she could only hide. This heresy challenged the very identity of the submarine officer. Captains were trained to be aggressive. Attack, attack, attack. The Tullibee demanded a different mindset. It demanded patience. It demanded passivity. It asked the captain to sit in a hole and wait. The cost of heresy was not just financial. Though the Tullibee was expensive to build and maintain, it was doctrinal. The Navy looked at this ship and saw a technological marvel that was tactically useless. They saw a brilliant answer to the wrong question. They wanted a wolf. The Tullibee was a spider. But as the ship moved through her trials, the engineers began to realize that the spider might be deadlier than the wolf. The heresies were working. The sphere was seeing things no one else could see. The motor was silent. The angled tubes could fire wire-guided torpedoes that could steer themselves. The Tullibee was not a failed experiment. She was a premature evolution. She was a glimpse of a future where information would matter more than horsepower. But in 1960, the Navy wasn't ready for the future. They were fighting the Cold War, and in the Cold War, they wanted muscle. The Tullibee was all brain. As the crew trained on their strange, silent boat, they began to feel a sense of elitism mixed with paranoia. They knew they were different. They knew the rest of the fleet laughed at their speed. But they also knew that in a war game, they were the ones who always won the first shot. The heresies were about to be put to the test. The acoustic trials were coming. The Tullibee was going to have to prove that being slow and weird was better than being fast and normal. By 1963, the theoretical promise of the USS Tullibee had to be reconciled with the operational reality of the Atlantic Ocean. The ship had spent years in the yards, her systems tweaked by engineers who treated her more like a spacecraft than a warship. But a submarine is not a laboratory instrument, it is a weapon, and weapons are judged by whether they can kill. To validate the concept of the hunter-killer submarine, the U.S. Navy scheduled a definitive test. It was not a simple drill, it was a duel. The Tullibee was ordered to the deep waters south of Bermuda. Her opponent would be the USS Skipjack. The Skipjack, SSN 585, was the crown jewel of the conventional nuclear fleet. She was fast, aggressive, and commanded by officers who believed in the doctrine of speed. To the crew of the Skipjack, the Tullibee was a curiosity, a slow, heavy, electric boat that belonged in a museum, not on the front line. They expected to find her quickly, simulate a torpedo shot, and be back in port for cocktails. The parameters of the exercise were simple. The two submarines were assigned a patrol box, a defined area of ocean. They were to hunt each other. The first captain to gain a firing solution won. As the exercise began, the Skipjack did what she was built to do. She sprinted. She moved through the box at high speed, her powerful sonar arrays sweeping the water, listening for the mechanical noise of the Tullibee. Her captain assumed that he would hear the Tullibee's pumps or the whine of her machinery long before she heard him. He was relying on the acoustic advantage that American nuclear submarines had always enjoyed over their diesel predecessors. But the ocean was empty. The sonar operators on the Skipjack adjusted their gain. They filtered out the biological noise. They listened to the deep sound channel. They heard nothing. Meanwhile, aboard the Tullibee, the world was very different. The Tullibee was drifting. She was making 3 knots. Her turbo-electric drive was turning the shaft with a silence that defied the laws of friction. Her reactor was in a low-flow state. She was effectively a hole in the water, but her eyes were wide open. The BQQ-2 spherical sonar array was feeding a stream of data into the fire control center. The sphere was listening in 3 dimensions. It picked up the Skipjack almost immediately. The Skipjack was loud. Her reduction gears whined. Her propeller cavitated as she turned. To the Tullibee's sensors, she sounded like a freight train. The Tullibee's fire control team plotted the solution. They had the range, they had the bearing, they had the speed. Solution locked, the weapons officer whispered. Tube 1, simulated fire. The Tullibee sank the Skipjack. Then she moved to a new position and did it again, and again. For hours, the Tullibee stalked the Skipjack. She moved into her baffles. She trailed her. She circled her. It was a humiliation. The fastest ship in the world was being hunted by the slowest, and the fast ship didn't even know it. The Skipjack's captain, frustrated and confused, finally broke the rules of the exercise. He ordered his ship to go active. He used his active sonar to ping the water, desperate to find the ghost. The ping hit the Tullibee. The hull rang. The Skipjack had found her. But in a real war, the Skipjack would have been dead 20 minutes ago. The active sonar was an admission of defeat. When the exercise ended and the data was analyzed, the result was a shock to the system. The acoustic logs proved that the Tullibee had detected the Skipjack at ranges that were previously considered impossible. And crucially, the Skipjack had never detected the Tullibee passively. The ghost in the exercise had proven the concept. Silence was the ultimate weapon. But the Tullibee had another trick up her sleeve. She was equipped with a system known as PUFS, Passive Underwater Fire Control Feasibility System. This was a set of 3 sonar arrays mounted along the length of the hull, looking like shark fins. PUFS allowed the Tullibee to triangulate a target's range instantly without maneuvering. In a standard submarine, to find the range to a target, you have to turn the ship to get a different angle. This takes time and makes noise. With PUFS, the Tullibee could get a firing solution while swimming in a straight line. This capability, combined with the spherical sonar, made the Tullibee a sniper. She could shoot first from further away, with greater accuracy than any other boat in the fleet. However, the victory in Bermuda was not the end of the story. In 1964, the Tullibee participated in a massive NATO exercise in the Atlantic. This time, the hunters were not just one submarine, but an entire fleet. Destroyers, frigates, helicopters, and patrol planes were tasked with finding the Tullibee. It was a test of the hunter-killer against the wolf pack. The NATO force threw everything they had at the problem. They dropped sonobuoys, they dipped active sonar, they saturated the ocean with sound. The Tullibee vanished. She used the thermal layers of the Atlantic to hide. She moved slowly, masking her noise behind the background clutter of the ocean. She drifted under the destroyer screens. She sat on the bottom. For 48 hours, the NATO fleet hunted a phantom. They reported possible contacts, only to find they were tracking whales or thermal anomalies. They dropped practice depth charges on empty water. When the exercise ended, the Tullibee surfaced in the middle of the formation. She signaled green flare, the code for mission complete. The Commodore on the flagship looked out at the stubby black hull bobbing in the swell. He realized that his destroyers, the pride of the fleet, were defenseless against a ship they couldn't hear. "Where were you?" he signaled. The Tullibee's reply was not recorded in the official history, but the legend says the captain simply pointed down. Right here. The Tullibee had humiliated the surface navy. She had proven that a quiet submarine was invincible against surface ships. But this success created a new problem. The Tullibee was too successful. She was so good that she threatened the budget of every other program. If the Tullibee was the future, then the expensive new destroyers and the fast attack submarines were obsolete. The Navy hates to be told it is wrong. The reports from the exercise filtered up to Washington. The data was undeniable. The Tullibee was a masterpiece. But the admirals looked at the other numbers. They looked at the cost. They looked at the speed. And they looked at the Soviet threat. The Soviets were building hundreds of submarines. They were building them fast. The Tullibee was slow to build, hard to maintain, and expensive. The question wasn't, is the Tullibee good? The question was, can we build enough of them to matter? The ghost in the exercise had won the battle, but she was about to lose the war of procurement. The Navy didn't want a sniper. They wanted a cavalry charge. They wanted ships that could get to the fight, not sit and wait for it. The Tullibee had proven the unacceptable, that the Navy's doctrine of speed was flawed, and the Navy's response was to reject the proof. The experiment was a success, so the patient had to be euthanized. As the Tullibee returned to New London, her crew felt invincible. They didn't know that the decision to cancel their class had already been made. They were the ghosts of the fleet, but ghosts don't get funding. The silence they had mastered was about to become the silence of obscurity. In the austere conference rooms of the Pentagon, where the future of the United States Navy was decided not by sonar contacts but by budget spreadsheets, the victory of the USS Tullibee was met with a cold, bureaucratic silence. The acoustic trials had been a triumph. The NATO exercises had been a humiliation for the surface fleet. The data was irrefutable. The Tullibee was the quietest submarine in the world, a vessel that could vanish at will and kill with impunity. But in the calculus of 1965, perfection was a liability. The Tullibee had committed the sin of being too expensive to build and too slow to fit the doctrine. The decision to cancel the class was driven by a collision of economics and strategic anxiety. The Vietnam War was beginning to consume the defense budget with a voracious appetite. The Navy needed to build a fleet that could project power globally, not just hide in the choke points of the Atlantic. They needed numbers. The cost analysis was brutal. The turbo-electric drive system was a bespoke piece of engineering. It required specialized manufacturing, heavy copper components, and a level of maintenance that drove operating costs through the roof. The S2C reactor was unique to the ship, meaning the Navy had to maintain a separate supply chain for fuel, parts, and training. For the price of one Tullibee, the Navy could build nearly 2 Sturgeon-class submarines. The Sturgeon was louder, yes, it used reduction gears, but it was fast, capable of over 25 knots. It carried more weapons. It used the standardized S5W reactor. It was the Ford F-150 of submarines, reliable, versatile, and mass-producible. The Tullibee was a handcrafted Formula One car. But the final nail in the coffin was speed. Intelligence reports from the Soviet Union indicated a terrifying evolution in their submarine force. The new Victor and Charlie-class submarines were capable of speeds exceeding 30 knots. The Soviet doctrine was aggressive. They planned to sprint into the Atlantic, attacking convoys and carrier groups with overwhelming force. Against a 30-knot enemy, a 15-knot Tullibee was a liability. She could not intercept. She could not reposition. If a convoy was attacked 50 miles away, the Tullibee would take 3 hours to get there. By then, the battle would be over. The admirals argued that speed is life. They believed that the ability to run away from a torpedo was just as important as the ability to avoid detection. They viewed the Tullibee as a stationary pillbox in a war of maneuver. So, the order was given. There would be no Tullibee 2. The hull number SSN 597 would stand alone. The experiment was over. For the crew, this rejection was a personal insult. They knew their ship was superior. They knew that in a one-on-one fight they would win every time because they would shoot first. They argued that speed didn't matter if you were dead before you knew the enemy was there. But their voices were drowned out by the roar of the military-industrial complex. The Navy doubled down on the fast-attack submarine. The Los Angeles class was authorized, a high-speed hunter designed to chase down Soviet carriers. It was fast, powerful, and expensive, and it used reduction gears. The electric ghost had been exercised. However, the rejection of the Tullibee coincided with a catastrophic failure of American intelligence that would eventually prove the Tullibee right. In 1967, John Walker walked into the Soviet embassy in Washington, D.C. For the next 18 years, he sold the keys to the U.S. Navy's cryptographic systems. The Soviets read the American mail. They learned exactly how the U.S. tracked their submarines. They learned about the acoustic signatures. Armed with this knowledge, the Soviet Navy began a massive program of quieting. They fixed their propellers, they rafted their machinery. By the mid-1980s, the new Soviet Akula class was shocking Western analysts. It was quiet, very quiet. Suddenly, the acoustic advantage of the Los Angeles class, the margin of safety that allowed them to be loud but still win, evaporated. The ocean became a place of parody. American submarines were struggling to hear the enemy. In this new reality, the Tullibee, the rejected experiment, became more relevant than ever. While the fast attack boats were struggling to track the Akulas, the Tullibee was still out there. She was old, tired, and maintenance-heavy, but she was still the quietest thing in the water. She was deployed to the Mediterranean. She sat in the choke points. She tracked the new Soviet boats when no one else could. She became a legend in the intelligence community. The building might be slow, but she had the best ears in the business. This created a profound irony. The Navy had rejected the Tullibee because they thought the future was speed, but the future turned out to be silence. The Soviets had moved toward the Tullibee model, stealth, while the Americans had moved toward the Skipjack model, speed. The Tullibee spent the 1970s and 80s proving the admirals wrong, one patrol at a time. But she was lonely. She was a single ship in a fleet of hundreds. Her crew struggled to keep the unique machinery running. They cannibalized parts. They improvised repairs. They wore their silent service dolphins with a pride that bordered on arrogance. They knew they were the last of a breed. The rejection and the reality act of the story highlights the tension between innovation and institutional inertia. The Navy is a conservative organization. It trusts what it knows. It knows gears. It knows steam. It does not trust electricity. The Tullibee was a victim of her own uniqueness. She was too different to survive in a standardized fleet. But as the Cold War entered its final, most dangerous phase, the Tullibee was about to have one last moment in the sun. The Mediterranean was heating up. The United States was on a collision course with Libya, and in a real shooting war, the rules of engagement change. Speed doesn't matter if you're ambushing a surface fleet. The quiet hunter was getting ready for her final act. She was old, she was slow, and she was unwanted, but she was still the only ship that could see without being seen. And in the shallow, noisy waters of the Med, that was the only thing that mattered. By the mid-1980s, the USS Tullibee was no longer just a submarine. She was a relic. In the fast-paced, digital world of the late Cold War, where the new Los Angeles-class boats were running on computerized fire control systems and the Soviet Akulas were diving to extreme depths, the Tullibee seemed like a ghost from another era. Her hull was tired, scarred by thousands of pressure cycles. Her reactor was old. Her crew spent more time fixing the ship than sailing her. To the young sailors joining the fleet, SSN 597 was a hangar queen. a ship that looked good on paper but was too fragile for the real world. But in 1986, the real world came looking for her. Tensions in the Mediterranean were at a boiling point. The United States and Libya were locked in a cycle of provocation and retaliation. Muammar Gaddafi had declared a line of death across the Gulf of Sidra, claiming the international waters as Libyan territory. The U.S. Navy was sent in to cross that line. The surface fleet, the carriers America, Coral Sea, and Saratoga, was the hammer. But the Navy needed a scalpel. They needed a submarine that could slip into the shallow, noisy waters of the Gulf, track the Libyan patrol boats, and monitor the Soviet ships that were shadowing the American fleet. They needed the Tullibee. The Mediterranean is a difficult acoustic environment. It is loud, crowded with shipping traffic, and filled with biologics, noisy marine life. In shallow water, sonar bounces off the bottom and the surface, creating a chaotic mess of echoes. A fast, loud submarine is blind here. The noise of its own engines washes out the sensors. But the Tullibee thrived in chaos. She entered the Gulf of Sidra running on her electric drive. She moved at 3 knots. She was silent. Her massive BQQ-2 sonar sphere, designed 20 years earlier, was still the best ear in the business for this kind of work. It could pick out the high-speed screws of a Libyan missile boat amidst the background noise of the surf. For weeks, the Tullibee sat on the line. She tracked the Libyan Navy. She tracked the Soviet Victor-class submarines that were trying to spy on the American carriers. She fed targeting data to the fleet. She was never detected. The Libyan frigates swept the area with active sonar. The Soviet submarines listened with their advanced arrays. But the Tullibee was a hole in the water. She was doing exactly what she was built to do, hunting without being hunted. This deployment was the silent vindication of the concept. The ship that the Navy had rejected as too slow and too expensive proved that in a real combat environment, stealth was the only thing that mattered. The Tullibee didn't need to run away because no one knew she was there. But vindication does not buy spare parts. When the Tullibee returned to port, the reality of her age was undeniable. The cost of keeping the unique propulsion system running was astronomical. The hull was reaching the end of its safe service life. The Cold War was winding down, and the budget was shrinking again. On June 25, 1988, the order came down. Decommissioning. The ceremony was quiet. There were no admirals making speeches about the future. The crew stood on the pier, watching the flag come down for the last time. They knew they were the last of a breed. There would be no more turbo-electric submarines. The Tullibee was towed to the Puget Sound Naval Shipyard. She was put into the recycling program. The reactor compartment was cut out and buried in the desert at Hanford. The hull was sliced into sections and melted down. The electric ghost was erased. It seemed that the experiment had finally failed. The reduction gear had won. The noisy, fast submarines had inherited the Earth. But history has a way of circling back. In the early 2000s, the U.S. Navy began planning the replacement for the Ohio-class ballistic missile submarines. This new class, the Columbia, would be the most important ship in the fleet, carrying the nuclear deterrent well into the 2080s. The engineers looked at the threat environment. The oceans were getting transparent. Drones, satellites, and advanced processing were making it harder to hide. To survive, the Columbia would need to be quieter than any submarine ever built. They looked at the reduction gears. They realized that mechanical transmission had reached its limit. You could not grind the gears any smoother. You could not make the rafts any softer. To get quieter, you had to get rid of the connection. You had to go electric. In 2013, the Navy announced the design for the Columbia. It would feature an integrated power system, a turbo-electric drive. The technology had finally caught up to the Tullibee. Modern permanent magnet motors were smaller, lighter, and more powerful than the massive DC motor of 1960. Solid-state electronics had replaced the heavy switching gear. The cost was manageable. 50 years after the Tullibee was canceled, her core philosophy became the standard for the most advanced submarine in the world. The legacy of negative knowledge had transformed into positive doctrine. The Navy had learned what not to do in 1960 so that they could do it right in 2020. The Tullibee was not a failure. She was a prophecy. She predicted the sensor revolution. She predicted the dominance of passive sonar, and she predicted the return of the electric drive. She was just too early. As the first steel is cut for the Columbia class, The ghost of SSN 597 is in the room. Every quiet patrol, every undetected transit, every moment of silence in the deep ocean owes a debt to the unwanted experiment. The Tullibee was the submarine too quiet to copy until the world got loud enough to need her silence again. The story of the USS Tullibee is a parable about the tension between innovation and timing. In technology, being right is not enough. You have to be right at the right time. The Tullibee was right about the physics, but wrong about the economics. It challenges our obsession with the new and the fast. In warfare, as in life, we are often seduced by speed and power. We want the hot rod, we want the fighter jet. But the Tullibee reminds us that sometimes the most powerful thing you can do is sit still and listen. There is a quiet dignity in her service. She did the hard, lonely work of being the prototype. She suffered the breakdowns and the ridicule so that the future could be perfect. As we look at the modern fleet, we see the echoes of the Tullibee everywhere. The spherical sonar domes, the amidships torpedo tubes, the obsession with acoustic hygiene, these are her children. The ocean is vast and indifferent. It swallows ships and men without memory. But the Tullibee left a mark that cannot be erased. She proved that silence is not just the absence of sound. It is a weapon. And in the deep, dark water where the next war will be decided, that weapon is still the deadliest one of all. If this deep dive into the hidden history of the Cold War and the engineering of the silent service meant something to you, we'd be honored to have you with us again. Until next time, stay curious and take good care.